All right, today we're jumping into a real mathematical cold case. I'm talking about a problem so thorny that for centuries it was considered totally impossible to solve with a perfect, exact answer. We're going to follow the clues and see how a completely new way of thinking finally cracked it wide open.
And this is our crime scene, an 18th degree polynomial. It's an absolute monster. Just look at all those numbers, the coefficients defining this thing. Finding the exact values of x that make this whole mess equal 0? It seems impossible. But, as we're about to find out, every monster has a weakness.
So why is this particular equation such a big deal? I mean, it's not just that it's long and looks messy, it represents a whole class of problems that have stumped the greatest mathematical minds for ages, really pushing the boundaries of what we even thought was solvable.
To really get why this was such a tough nut to crack, we've got to look at classical algebra. You've got these famous theorems like Abel's theorem, which basically put up a giant do not enter sign. It told mathematicians, look, for high-degree polynomials like this one, you're just not going to find a neat, exact solution with the tools you have. For all intents and purposes, the case was considered closed.
Now hold on. What do we even mean by an exact solution? Well, think of it this way. It's the difference between having a suspect's precise height, weight, and DNA profile versus just a blurry security camera photo. A numerical approximation gets you close, but an exact symbolic root, that is the perfect answer. It's the mathematical fingerprint, and that's what we're after.
So how did people try to tackle these things in the past? They had their methods, of course, but as we're about to see, these old investigative techniques had some serious blind spots when they came face to face with a case this complex.
The classic approaches, like Newton's method, are actually pretty clever, but at their core, they're really just a process of making very, very educated guesses. They kind of circle around the answer, getting closer and closer with each step. The problem is, tiny rounding errors always creep in. For a beast like our polynomial, those little errors build up and up, meaning you can never be 100% certain you have the exact value. It's like trying to identify a suspect from a blurry sketch instead of a crystal-clear photograph.
But what if a new detective showed up on the scene? One with a completely different method, a secret weapon that could just bypass all those old problems and get straight to the truth. Well, this is where Ezeudi's theorem enters the story. Ezeudi's theorem is a total game changer. See, instead of guessing or approximating, it uses what's called a recursive process. Just think of it like a series of repeating steps, where the result of one step feeds directly into the next. This lets it systematically transform the polynomial, piece by piece, completely avoiding those nasty rounding errors that plagued all the old methods. Okay, so how does this new detective actually work its magic? Let's follow the clues. We're going to apply the theorem to our monster polynomial and just watch as it starts to break it down, revealing the secrets that are hidden deep inside. So here's the game plan. The theorem is going to take all those original messy coefficients from our polynomial and then run them through a special recursive formula. The whole point is to calculate a brand new set of coefficients, which we'll just call S, and we're hoping this new set is a lot simpler than the one we started with. And boom, right away we get our first big break in the case. After running the numbers, the very first new coefficient, S0, simplifies all the way down to a perfect 0. Okay, interesting. The complexity is already starting to melt away. And then the clues just start pouring in. The next coefficient, S1, is also 0. And so is S2 and S3, S4, S5, all the way to S7. Just like that, 8 incredibly complicated terms from our original monster have just vanished. Poof, gone. But just when it seems like everything is going to disappear, we hit something solid. The ninth coefficient in our new set, S8, does not equal 0. This is it. This is our first piece of hard evidence, a crucial number that actually survived the simplification process. This is the clue that's gonna crack the whole case. So when we lay out all the evidence, the pattern is it's stunning. Of the 18 new coefficients we calculated, almost every single one of them is 0. Only 2 are left standing, SPUT 8 and SPUT 17. Our monstrous 18-term problem has been boiled down to just 2 essential numbers. All right, we've followed the clues, we've got our key pieces of evidence. Now it's time for the final reveal. Let's take what we've learned and finally unmask the answer. Remember this thing? This was our starting point. An intimidating wall of numbers and variables that looked, for all the world, like it was unsolvable in its perfect, exact form.
And this just brilliantly shows the power of Izuidi's method. Our monster equation transforms into this beautifully simple structure. You see? All those messy middle terms have vanished, leaving behind only the parts connected to our two non-zero clues, S8 and S17.
So now we just substitute in the actual values we found during our investigation. The elegant structure is still there, but now it's filled in with the two crucial numbers that define this entire problem. And this is something we can actually solve.
And with that, all the pieces of the puzzle just click into place. We took an unsolvable mess and we transformed it into a clear, solvable equation. We now have a precise formula, a direct path to the answer with 0 approximations and 0 rounding errors. This is the key that unlocks the whole thing. Case closed.
And that leaves us with a really fascinating thought, doesn't it? This wasn't just about solving one tricky polynomial. It was about proving that a new perspective, a brand new tool, can make the impossible possible. It really makes you wonder, what other great unsolvable problems are out there just waiting for their own detective to show up with a brand new way of thinking?